Welcome back, and let's take a look at some conjoined triangles ideas. So I'm going to go ahead and find that topic. I know I can find that topic by taking a look at our similar triangles, work in here, skills, solve for side conjoined triangles, level 1. Okay, so let's take a look at some of these triangles. Aha! In the trapezoid below, okay, OP is parallel to LM. All right, now let's see what we can do to find. Okay, so ON, what are we looking for? ON is 12, NM is 10.5, and NP is 4.5, and we want to find LN. All right, so let's take a look at which triangles are similar in this diagram. There's only two similar triangles here. The rest have no relationship to one another. And I'll show you why they're similar and then how we can use the power of ratios to solve this. So again, get out your paper. Clear your paper. If you're using magical paper like I have, hey, pretty cool. I like this whole system here. And now I'm going to get a, we'll do this in blue, sure, but I'll do it in a bit of a fatter pen. Okay, sure, whatever. So I'm going to redraw the diagram. There is LO. Okay, point P is up here somewhere. I just put it on and then connect them. Okay, and then M is down here. Wait, this is parallel, so that's parallel, so it's something like that. Okay, this is point M, and then here is M to O. Here is L to M. This is parallel with this, I promise, and this goes through here. All right, so now, what can we tell from this? Well, we have two parallel lines, and they're being crossed by this line. That tells me I have Z pattern here. And the angles in the corner of the Z pattern, this is theta, and that's theta. They're the same. Okay, I'm just going to remove the Z pattern, but I'm going to leave on theta is the same, and theta is the same. Okay, but also these ones here, this is beta, and this is beta. That is X pattern. They're across from one another. All right. And if two triangles share two angles that are the same, then you can be darn well sure that this would be alpha and that would be alpha. They would be the same. Okay. They're also Z pattern through this line there. So that's one way to show that they're the same, is that Z. But also just theta plus beta plus alpha is 180. So theta plus beta plus the same alpha is 180. Okay. So triangle LN, this is the point N in here. See N. Triangle LNM is congruent with, similar with ONP. And O corresponds with L, M corresponds with P. Okay, so now let's put on our, I'm going to have to zoom in and put on our distances, our lengths. ON is 12. Okay, so this is 12 long here. Okay, and NM is 10.5 and NP is 4.5. NM is 10.5. NM is 10.5. Wow, my diagram is way different than theirs, but it's fine. 10.5. And NP is 4.5. Okay. All right, so this one is 4.5. That one is 10.5. This is 12. And this is the one we're trying to solve, right? LN. Yes, this one, LN. So I'm just going to put a question mark there. All right. Now, I'm going to maximize my diagram here, move my face that is annoyingly in the way, and take a look at this. All right, now I draw the triangles isolated. So I want to organize them in the easiest way possible. So this triangle, it corresponds with that triangle. They're similar, but the sides correspond. You look, okay, this is angle beta and angle alpha. So this side is the side that goes between those two angles. This is angle beta, angle alpha. So it corresponds to that side. This side goes between angle beta and angle theta. So it corresponds to this side, which goes between angle beta and angle theta. You have to get your sides of correspondence right. So what I'm going to imagine is I'm going to rotate this triangle around so that it lines up in the same way as this one. Okay? And I'll draw this one in blue and this one in orange. So here is N. And then I'm rotating around, so O comes around, and here's O. Okay, and then P is over here. All right, and I have the following side lengths. Okay, so NP was 4.5, and O was 12. This side, I don't know, don't care. All right, now this one here, let's draw that triangle. As I said, I promised you I would draw it in orange. Just gonna make this a little smaller and move this there. And then notice, because I rotated that one, I don't need to rotate this one, and then all the sides line up nicely. Okay, this is L, N, M. Okay, and this side is 10.5, and this side is, I don't know, call it X. Okay, now we want to solve for X. So now that I have these organized, see the value of writing this in a nice way? I don't need to rotate that in my brain. And I can see that this corresponds to that, so this is going to correspond to that. So when I set up my ratios, I'm going to put my unknown on the top. So I'm going to have X over something is equal to 10.5 over something. What are they over? The knowns in this triangle. X over 12, because this corresponds with this, is the same as 10.5 over 4.5. All right, cool. Let's reduce this. No, let's just cross multiply. So now what I can do is 1.
Sorry to interrupt, but why'd you do X over 12?
See how this side corresponds with that side? That would mean this side also corresponds with that side.
Okay.
And because the two triangles are similar, the ratio of this side to that is the same as the ratio of this side to that.
Okay.
Okay. And that's the whole point of rotating this triangle around. Between B and angle alpha, this side corresponds with that side, because this is angle alpha, this is angle beta, and then this is angle theta and angle beta. So this side corresponds with that side. But rather than doing that and just doing it in my head, which I would do, but I played a lot of jigsaw puzzles. I'm used to rotating things around in my head and imagining what they look like. I don't know how many jigsaw puzzles you've done, Johnny. So I drew the triangle rotated around so that all the sides like correspond with the ones that are lined up in that way. Okay. So now a quick inverse operation of multiplying both sides by 12 will isolate X. Okay. So X is equal to 10.5 times 12 over 4.5. Okay, and 10.5 over 4.5 is the same thing as, I'm going to do this without a calculator. 10.5 over 4.5, divide each by 1.5, because 1.5 is a factor for both. So that would be over 3. If I divide this by 1.5, that's 3. And 10.5 divided by 1.5 is 9 would be 6. So this is 7. 7 over 3 times 12. Okay, the 3 cancels the 3 and the 12, makes it a 4. So X is equal to 28. Okay, if you don't believe me with my fancy mental math, yes, you can do this on a calculator, but you don't have to. You can do it with mental math. You do it this way: 10.5 divided by 4.5 will equal 7 over 3. That's 7 over 3 times 12 equals 28. There you go. So let's put in 28 into delta math.
Wait, so with those ones?
Yeah.
I don't know how to explain it. We've been doing like the tan and stuff. We don't do that for that one?
No need.
Oh.
Well, you can't. Why? How could you? How could you use trigonometric ratios? I'll show you why you can't. What do we need? What angle do we need at this point in our mathematical development to use trigonometric ratios?
We need the angle.
Yeah. Have we been given any angles here?
No.
No. Yeah. What other kind of angle do we need at this point?
Oh, okay.
We
I
don't
see.
have any of those. So we can't use trig. And in fact, this is a shape that could be any number of shapes because we don't know how long this is. This was not given to us, and this was not given to us, and no angles were given to us either. Okay, so actually, you could take that. It's like an X, and you could change it that way. And by changing it, you would be changing the length of those other sides. So there's actually no way, as far as I can tell, just by looking at this. No, there's not. There's no way that I can solve for angle B, angle D's. There's no way I can solve for LM because PO was not given. Okay, so it's not a single shape. However, because of the similarity of the angles and the similarity of the triangles, regardless of how long that is, it would determine the length of this because of the Z patterns and the shared angles between the two triangles. So this is definitely solvable. This is not solvable. But with trig, I could solve all the sides. If I told you that, say, angle A was 30 degrees, it's possible, it could be 30 degrees. Now I could solve the whole thing using trig. The trig we're going to use next week.
Okay, I see now.
Awesome.
I'm gonna go try doing those because I don't know how. Now I'm trying to think of how I use trig with that, but
Yeah.
I did
Well,
it some
you used
way.
trig and you kept on getting wrong answers. So you were trying something. It wasn't working.
Okay, thank you.
By all means. All right, everyone. So thanks very much for hanging with me for that extra example.